Hello everyone, this is lecture 2 in the Throughput accounting series. Now, we will move on from lecture 1. Lecture 1 was just a brief introduction about what exactly is throughput accounting and the major assumption. So what we'll do is we'll dive in and see how we can use this terminology a little bit further. You will have to understand that throughput accounting is mostly adopted where companies have just-in-time system. And when you have a just-in-time system, you want to make use or best use of your resources, be it materials or labor. And sometimes what happens is, let's say, for example, we take a car manufacturing unit, and you want to make the best of your resources. And sometimes, if you get an order for 100 cars, obviously your aim is to make 100 cars. But what we may notice is that things may not go as planned. And when things don't go as planned, meaning there might be some production areas which can hamper the speed with which we want to produce that 100 units, we call that bottlenecks. And the idea is not to talk about bottlenecks, although we can talk about it a little bit later. But normally, throughput accounting, we tend to use it in a just-in-time system. So just-in-time system, or JIT, just-in-time system. And with just-in-time system that the aim is we want to reduce as far as possible the stock capacity. So we don't want overstocking. So let's go back to this example here. So we're told the company makes models of scalp, eider, and teal, or whatever that is. The throughput contribution is 90 pounds, 80 pounds, and 50 pounds respectively. Now, if you don't have a clue of what throughput contribution is, stop this lecture and go back to lecture 1, and then you can come back. We are told there are 3 wood carvers employed, and the hours they need to work per unit are given below. So we have 3 products, scalp, eider, and teal, and we have 3 wood carvers. So we have Brian, Tim, and Janice, and these are the labor hours per unit that they take to manufacture each product. Let's move on. We are told estimated demand is 200 sculptures of each duck. So I gather these are duck sculptures. Um, each sculptor is only available to work 480 hours in the period. Total factory cost is 4,320 pounds, and we'll come to that later. The deal is this. Let's try to see which activity is the bottleneck here. Let's try to go and see which activity is the bottleneck. We'll take it step by step, and then you will see how throughput accounting comes into the picture a little bit later. To do that, first of all, if we take scalp, so scalp, remember the estimated demand is 200 sculptures. So for Brian, equal 200 multiplied by 2. So that's 400. Either, well, excuse me, 200 multiplied by the 1. So that's 200. And then equal 200 multiplied by 0.25. Yes, so in total, let's sum this up. Brian will take 650 hours. Now, straight away you see that there um, seem to be an issue because we're told, well, each sculptor is only available to work 480 hours. We'll look at that later. Let's complete this little table here. So remember, um, demand is 200, so equal 200 multiplied by 1.80, 360. And we're looking at Tim. So 200, multiply by 2, that's 400. Finally, equal 200 multiplied by 0.50. Yes, so what I'm doing, I'm just calculating the total time that each labor takes to manufacture each of these three products, scalp, eider, and till. And let's complete the table. So Janice equal 200 multiplied by 1.5, 200 multiplied by, well, 0.5, and finally equal 200 multiplied by 0.25. So let's try to sum these up. Okay, now Brian, total, so these are, if you want the total labor hours, Brian takes 650, Tim 860, Janice 840, 450, sorry. Let's try to work out, well, what exactly is overcapacity. Now we can see that there already that there seems to be a problem here because Janice looks fine. She's well below the 480 hours, but we seem to have a problem with Brian and Tim. So let's try to work out what the overcapacity is. So with that, we take, well, 650 divided by 480 equal 650 divided by equal 860 divided by 480. And finally, equal 450 divided by 480. All right. Now you can convert that to into percentage, but I, don't really see the point. You can already see what's happening here, and you can see that in terms of overcapacity, well, we have a problem with team. If because sorry, this comes to 1.79, and if we were to rank which worker we would prefer, or if we're to rank the order of production, we would say, well, okay, we concentrate on Janice, then Brian, finally Tim. So let's stop the lecture here, and before we do so, uh, at the start of lecture I talked about bottlenecks. So in our case, well, clearly Tim appears to be the bottleneck. I will stop the lecture here and I'll see you in the next video.